Sorry for the break. I was having trouble with my internet, but I'm back now. Yes, so as I was saying, the data, hope everyone can hear me still. Please just send a message in the chat window if you can hear me clearly, so that I know that everyone is with me. Please mute your microphones if you've not already done so. Yes, so as I was saying, the data frame. So I'll just run this code to show what my data frame looks like. Now, as you can see, it's a data frame with 3 columns or 3 variables. Like I said, the columns are variables. So the first column holds the name of the person, the second column holds their age, and the third column holds their sex. And then we have the rows, which represent a single individual in the data frame. So we can use the glimpse function to have a look at our data frame. It shows us now each column, apart from having the same length, each column has to have the same type. So the first column is a factor, the second column is an age or a double, which is a number, and the third column is also a factor. And that's one of the key differences between data frames and tables. A table is a data frame, but it's just a data frame inside Tidyverse. And there are a few key differences between them, while they are also quite similar. So first of all, tables handle strings differently from data frames. In a data frame, every string is converted to a factor. So if you look at the structure of this my data frame, you can see that even though I created the person data frame, the person column as a factor, as a string, sorry, it's showing up here as a factor because the data frame automatically converts every string to a factor. And that can be problematic. So what tables do is that they don't do this conversion, they just create everything the way you create it and they don't change anything. So first of all, let me show some ways to create tables. One way to create a table is to convert a data frame. So the as_table function, this one, converts data frames to tables. Now we have this my data frame that I created here. And I'm going to use that function to convert it to my table. So if I run this code, I have my table. If I press enter, we see the table here. Now, if you notice, this is another difference between tables and data frames. The data frame prints as is. It doesn't give you any extra information. It just gives you the data like a matrix with columns and row numbers. But the table gives you information. It tells you the number of rows. The row number comes first. So it tells you that there are 5 rows and 3 columns. Underneath the names of the columns, it also gives you what type each of the columns are. And because I converted that data frame to a table, it's still the same type, factor, double, factor. Now, another way of creating tables is to use the table function. You just type table, like data frame, but you list out the columns as vectors and separate them by commas. So the first column I named person. I created a vector using the C function, and I listed out each member of that vector. Then I put a comma and did the same for the age and did the same for the sex. Taking note that all the 3 must have the same length. If anyone has a different length, it won't work. So if I were to have a mistake and put 6 values in the age, this code will not work. So as it is now, if I run it, I have my table 2. I named the table my table 2. Now if I run my table 2, we can see the table. Now it's the same 5 rows, 3 columns, and under the person is now a character. If you note from the first the data frame we created, the first column was converted, all the characters are converted to factors. But that's not the case here. The character remains as a character, the age is a double, and the sex is also a character. So that's like the common way of creating tables. You just use the table function and list each row in the table. Then the third way is to use the Tibble function. Now Tibble is just short for transpose table, and it allows you type in the code for the table in a more visible manner. So if you notice, for this table function, I had to list out in a row each one and separate it by commas. But here in this function, you can list them individually. First of all, you create the column names by putting this tilde sign and then putting the name of the column. So this sign is required. So first you type Tibble, and then you put the person, the age, and then the sex. And after that, you list the members of each group. If you note, the way they are listed is such a way that you can instantly see the demarcations and the structure of the table. And if I run this code, it just does the exact same thing as the table function, but presents it in an easier to see way. So those are the three common ways of creating tables. And in doing so, we've created 3 tables. Now we can glimpse them. When you use the glimpse function, is in the deep dive package, which is also in Tibbles. When you use the glimpse function,
if you come and see me, you know what happened. Thank God there is part.
Okay, someone's mic came on. I've muted it. So when you use the glimpse function, you have a glimpse, as it says, into the table. So if I glimpse my table 1, it tells me the number of observations, that's the number of rows. It tells me the number of variables or the number of columns, and then it tells me both the name and type of each of the columns. So if I were to glimpse my table 3, same thing, just says 5 observations, 3 variables, person, character, age, double, sex, character. So that's that for creating tables. It's actually quite to the point once you know what you're trying to create. Then we go on to printing and subsetting. Now another difference between the way tables print and the way data frames print. Now in a table, when you try to print a table, I'll give an example. Now this NYC flights, if you type this code just like this, packages also come with data sets. So if you type this code exactly like this, NYC flights 13 with 2 colons and then name flights, and you run it, it gives you access to the flights data set. It's a data set that comes with the NYC flights package and shows you, it lists all the flights that happened in New York in 2013, every day of 2013. So it's quite large. But you note that when I print it as in the table form, it first tells us how many rows, 336,000, and how many columns there are, 19. And then it lists the first 10 rows and the first few columns that it can. Now, these columns that are listed depend on how wide your window is. If you have a very wide window, it can list all, but it automatically fits the console so that it doesn't overwhelm your console with information. And then underneath that, you see the more information. It tells you, okay, there are this number more rows, 9 more variables, and it lists the remaining columns and tells you their type. So at a glance, you have a good idea of what the table contains. But data frames work differently. Now, if I convert this flight table to a data frame and I print that data frame, I've named it DF flight. So if I print that, you'll notice that it just prints the entirety of the data frame at once in your console. So that's not very easy to work with. And that's another major difference between tables and data frames. It's just bulk printed into your console and you have no idea what is what. Now, if we remember from the last class, we spoke about subsetting. That's where you try to select a small group from a larger data set. So subsetting also works differently in data frames and tables. So in a data frame, for example, I've created two data frames here. The first one is just two very small data frames with one column, two columns and one row. I've named the data frame df and the table df table. So now, when I try to, first of all, in data frames, if you know the name of the column, let's say you don't know the full name of the column, you just know one letter in the column, you can still print it, but tables don't work that way. For example, in a data frame, if I type df$x, note that the column here is xyz. But if I type df$x, it will still print it for me as I asked. But if I do it on the table, it doesn't work. It will say unknown or uninitiated column x. That's an error because there's no column x, there's a column xyz. If I change this to xyz instead of just x, it will work. So that's another difference between tables and data frames. Then we've already spoken about how data frames convert to factors, but tables don't. So that's just a basic idea of what a table is. It's just a data frame with some extra features that make it easier to work with. If you're working with tidyverse, most of the time it's better to work with tables as opposed to data frames because of how optimized they are to work in the tidyverse. So we'll move on to importing data with readr. Now readr is also another package within the tidyverse. It allows you reading a multiple different types of files. Now in R, if you need to do some analysis, usually you have a file, maybe a CSV file or some other large file that you need to bring into R. So I have a sample file which is on my desktop, and I want to read it into R. It's a CSV file. So now the readr package, it has multiple functions. There are about 1, 2, 3, 4, 5, 6, 7 of them. And these functions allow you to read files of different types. They all have similar formats and similar syntax. So once you know how to work with one, you know how to work with all of them. So the first is read.csv, read_csv. CSV means comma separated values, is a type of file in R. So let me just show a quick example of what a CSV file looks like before we load it in. So please hold on, let me load my CSV file. Okay. So I don't know if we can see the CSV file on screen. Okay, I don't think we can see it. Let me just quickly show the CSV file. Okay, so this is the CSV file. As you can see, it's just values separated by commas, comma, 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 comma. It doesn't look very sensible, but that's the way the file comes, and R is able to make sense of it. Okay, so back to our initial, yes. So in reading the CSV file, what you need to do now, the functions, they are different depending on the type of file. Now I showed the CSV file, but there are also TSV files, which are tab separated values, where the values are separated by tabs instead of commas. Then there's read_delim. Now sometimes the in certain places the comma separated value doesn't work, so some people separate with different characters. So read.delim allows you tell the file, the function, what character you want to use. And then there are fixed width files, table files, and log files. But we'll just demonstrate with a CSV file for now. Now, the first thing you need to do is to set your working directory. The working directory is the folder where you want your files to be stored, where you want R to look for the file you're going to pick. So to do that, there are two ways. One way is to just click the One way is to, sorry, can everyone see my screen? Please, just indicate in the chat window if you can see my RStudio window. Anyone? Okay, good. So everyone can see my window. So now, in reading this file, if I type read, I know the name of the folder. This is the name of the file I want to read. Now, without setting my working directory, if I just type file is equal to Billy_homicide.csv, it will work because the file is not in my working directory. So there are two ways to go about it. One is to set my working directory by clicking here, choose directory, and then picking the folder in question I want to use. Or you can type the code directly and say, so the function to set your working directory is called set working directory, set wd, and then you type in the full path to the folder you want to use as your working directory. So once that is done, when you try to read in files, RStudio will go to that folder you've specified and try to. Okay, so once that is done, it will read in your file. So now that I've set my working directory, if I try running read.csv again, you can see that it works. It reads in the file. It tells me the types of each column and the names of the columns. There are doubles, characters, date, time, and the like. And then it shows me a glimpse of the table, tells me how many rows, how many columns, and gives me more information. But the function has more arguments. The first argument is usually the file argument, which is the name of the file in question. You can either, if you set your working directory, you can type just the name of the file, or you can type the full path to the file. So let's say I didn't want to change my working directory and the file is in another folder. I can just type in the full path to the folder like this, and it will still work fine. Take note you're using forward slashes when you're typing the name of the file. Now the next argument is the call names argument, which what this means is it's asking you, does the first row in your file represent the names of columns? So some files will have it, some will not. That's why it's important to have a look at the file first. You can open the file in your notepad, have a look, and just see what it looks like before trying to read it in, so that you can supply these arguments. Now, if we set call names to true, it takes the first column as the name of the file. If we don't do that, it doesn't take it as name of the file and creates the first, it leaves the first column name blank. So in this case, we have the column name, so we just type true. And then call types. Now, usually the read function tries to guess the type of the column by looking at the files in the, by looking at the values in each cell. So it looks at like the first 1000 values and tries to guess. So for example, the first column, it sees that, okay, there are numbers, so this must be a double. But sometimes you may want to override that by, you can give it a vector of the types, but usually that's not needed. Then there's also the local argument, the missing, now for missing values, any, you just supply a vector telling it what represents missing values in your folder, in your file, sorry. And quoted any, true or not, that's, do missing values have quotes, and like, all till the end. Usually if you want to get a better idea of a read of any function really. You can just type question mark and the name of the function. And then RStudio will give you a help file telling you more, giving you more information. So for example, we have I just typed help read_CSV and then I pressed enter. And RStudio has given me this help file telling me what each of the arguments does and how you supply each argument. And it even gives you examples on how to use each of them. So it's very helpful. If you aren't sure how to work with it, you can just type in question mark read_CSV or read_any function or literally any function in R, and you get a very useful help file in your console window, or sorry, in your help window. So that's just an example of reading CSV files, and you can assign the value to a variable so that RStudio saves that variable. So for example, I've been reading files, but I've not been saving them, so I can't work with them. But if I wanted to work with these Philly homicides, I'll just assign it to a variable. Let's say Philly_homicides equal to read.csv this. Sorry. Okay. So now when I create it, when I click enter, we can see that I've created a new, in my environment window, we can see that I've created a new table from this CSV file. So now I've read in that file that was on my desktop into RStudio, and I can do any analysis or data work I need to do with the file. So that's a brief intro into reading CSV files. We can also read Excel files. There are functions to read Excel files as well, in XLS and XLSX format using the readxl package. Now, I loaded the readxl package from the beginning here. So that allows me to use the functions within the package to read Excel files. So I think we'll go on a short break for about 10 minutes or 5 minutes, just so you can have a look, and then we'll come back and continue from reading Excel files.